All right, what is up, everybody? Um, I got really good news. So before something I was extremely pissy about that was a Sierra College, Whitney High School, kind of like other people's fault thing. You can't do Calc 3 at Sierra College, or you can't enroll for it the regular way unless you got a 5 on the AP Calc BC. Yeah, on the AP Calculus BC test. The issue is though those scores come out in July, so that means I'm missing the entire summer, so I have to do an entire summer with nothing. I was really mad about that. And also mad that I couldn't take differential equations at the same time, but you know what, it's whatever. Anyway, I recently started taking an English class at Sierra College. I'm doing English and African American Studies. All right, that's the big two. African American Studies is completely online, but the English is in person. So I went to the English. It was fun, and I heard two kids talking in there. Hey, Calc 3 earlier, yada yada yada, whatever. Oh wow, they have Calc 3 earlier. So I go over to the math building when the English class is done. There's one guy in there, like one teacher. He's like, helping the student or whatever. I ask, hey, I heard there was a Calc 3 class today. Do you think the teacher would mind if I sat in? And the guy's like bellowing, oh no, not at all. Math teachers love when students do, and this guy is special, like he wouldn't mind at all for you to sit in. Okay. Stay up till about 4. Wake up. Go. I show up maybe like 2 minutes late to the lecture, which is a bad look because that's the third day they're lecturing and it's the first day I pull up because it goes math, and then English on Tuesday, math Monday, math English Tuesday. I hear about it on the English on Tuesday, so I'm missing Monday and Tuesday. I pull up Wednesday today, and I say, hey, I really love math. I'm not enrolled, but do you think I could just sit in? He says, sure, really enthusiastically. Talk to the guy after the class, and I'm like, hey, I was wondering if someone drops the class, do you think I'd be able to get credits? And he's like, oh yeah. I'll fill all the paperwork at the end. You're pretty much in the class already. My counselor, Mr. Blate, lies. BS. It's all fake. It's all a fugazi. It's a woozy, it's a wazi. That's from The Wolf of Wall Street. I'm not sure why I'm quoting that movie. Not really good people. Anyway, so yeah, I'm getting Calc 3 credits. And I'm going to be able to take differential equations, first part of my senior year. Calc 3 credits. And ethnic studies credits. And English credits. Finally got enough for a BA. I think I need elective or something else. I feel like I did shit on the AP Chem test, so I'm probably going to need something for that. Anyway, let's move OBS down here. So I don't really know what we got going on. For the Calc 3 class, I'm not really in the Canvas. I'm not really sure what the hell's going on in there. We have a quiz on something tomorrow. And it was sphere related. Let's see if I actually know what it is. Whoa, what the heck? Okay, there we go. I definitely should have set this up before I got on live. So yeah, let's change the mapping. Select one display. Okay, perfect. So, bro, my fuck ass food, bro. Fuck. The math problem essentially went, there's a hollow shell, like a circular shell described by this equation, and it was x squared plus y squared plus z squared minus 2x minus 4y minus 6z plus 10 equals 0. So immediately I start simplifying. X squared minus 2x plus 1. That fits, and then we can do, you know, a plus 1 over here. Plus y squared minus 4y plus 2. Or no, plus 4. Plus z squared minus 6z plus 9. And then we have plus 10 equals 1 plus 4 plus 9, which is what, 15? No, 14. And then if you cancel out the 10, which I'm just gonna erase that, cancel out the 10, you get 4. So then we have x minus 1 squared plus y minus 2 squared plus z minus 3 squared equals 4. If you plug that into Desmos 3D, you get a sphere with a radius of 2. Because again, it's the square root of, you know, this right here. Like that's the, yeah. Anyway, so the center is 1, 2, 3. And then radius equals 2. Again, y'all gotta remember that you know, and then it could also equal 0. So yeah, that was the first task. Find the center. And then we had to find where it intersects with the 3 planes. I see, cats don't really know their names. I don't know if that's occurred to you in like your 10 years living on this planet. You could call them Pinkie Pie, it's not going to do anything. I'm sorry, I had to explain to my sister that cats don't know their names. Because cats are kind of retarded. They're still better than dogs. So, we have to describe where they intersect with each plane. That is the XY plane, the XZ plane, and then the YZ plane. Let me pull up Desmos 3D. Desmos 3D. Is that tough? I feel like it's tough, me personally. Desmos 3D graphing calculator. Equals 4. So this is what we got. So the XY plane is this flat one that you're seeing like kind of like drawn in right here. Now technically there are other planes. There's the ZY plane, which is this flat line here. Like if we took this flat part and then we made like this box, like that's the ZY plane. And then the XZ plane is the same thing, but if you drew that like right there. So we have to find where the circle sliced off here, where it's sliced off here by this plane, and then where it's sliced off by this plane. Now, I don't know if you guys can tell. It doesn't touch the XY plane at all. At all, like flat out. That's because its radius is 2, but its center is 3 off the ground. There's a whole distance of like 1 unit. So for the intersection, I'm going to say 1 intersect XY plane as r equals 2, which is less than so this is essentially saying like it can't touch the XY plane at all, you know. The second one we're doing xy. Now we have to do xz. The xz plane, I don't know if y'all can see it. It only intersects at one point. And that's because the radius is 2 and it's moved out 2. So it's like we have this ball and it's slid over and we're essentially just nicking it. It's a tangent line. We're not even nicking it. It intersects at only one point. 2. And now what point is that, you might ask? Well, that depends on the center. Let's look at it from this way. So it intersects at x equals 1 and then z equals 3. Wow, that's crazy. That's how much it's actually moved over here. So x equals 1, z equals 3. And then that's where that's where the ball would touch right there. Intersects at 1 point. Intersects xz plane at 1 point. I did that in the wrong order. And then yeah, 1 0, because again the y value, this part right here, it has to be right here because that's where the plane is. We have 1 0 and then a 3 because it's 3 up. Now number 3, this is the tricky one. My webcam's in the way. This is the tricky one. We have to figure out where this intersects here. Now we can actually do this by just drawing out the curvature of a circle. So let's say we had a circle and then this was like the center or whatever, and then this also like went through its center. Let's call this 2 because you know it has a radius of 2. This is also 2 as it is a circle, and then this is at 1. Well, how do we figure out how tall this part is? Because this part is the radius of the circle it makes when it intercepts, right? This part is on, hold on. This part is on one side of the plane, and this part is on the other side of the plane because well, this part technically, because it intercepts right here. So I just plugged in the equation, x squared plus y squared. Oh wait, no, I might have used different variables to prevent confusion. Let's use I and j just for simplicity. I squared plus j squared equals 4. That gives us a circle with the radius 2. Now we want j, right? Because that's like the y value. That's like the height of, you know, that's the height that we want. That's the j value. That's the radius of the circle where it intercepts. So we do j squared equals 4 minus I squared. And then we just have j equals, let's just do like the absolute value, like only the plus part of this, and then we can do 4 minus I squared. Now what is I right here? What is that? Kind of tricky, I know. So let's rewrite that. 4 minus 3, which is just the square root of 3. So the radius of intersection here is the square root of 3. All right, so if we were writing that as an equation, we have we need to write, you know, like the actual like center, the center of like where it intercepts. Now this is where it intercepts the YZ plane. So I don't really know. Oh yeah, x is going to be 0 because it's intercepting at x equals 0, right? It's right there. And then y is going to be 1, 2, and then z is going to be 3. So we know it intercepts at 0 for x, 1, 2 for y, and 3 for z. Bro, actually, 0 for x, 2 for y right here, and then 3 for z. All right, perfect. So now we can draw a circle. This is going to be a circle because when a 3D shape is intersected by a 2D shape, like the cross section is two-dimensional. So what's the equation? Well, we already have the radius, right? So if the whole rest of the shebang equals r squared, then we can have 3 equals. And then what are the center points? 0, 2, and 3. So then we have y minus 2 squared plus z minus 3 squared. And if we do that, 3 equals y minus 2 squared plus z minus 3 squared. That looks kind of dumb, if I'm going to be honest. Bro, this is actually dumb. Oh, wait, no, I can just, like, set this. Negative 0.3 x 0. And that literally gives us exactly where it intercepts. Y'all can see, like, that line right there, like, that's where that would cut through. Damn, I don't even know. Homer drops his donut. Oh. Oh, if we do x equals 0, and then we turned, right, how do you make it like more transparent and shit? This is dumb. Oh, I like how they added like field of view, so it kind of adds a little like distortion. That's actually so dumb. Why can't... Hello? See, okay, we finally got translucent surfaces. Y'all can see the blue line is right where it intersects. So yeah, that solves that. Yeah. Now, my issue. All right, my issue is where the vectors come in. Because like we were taught about vectors in, you know, Calc BC or whatever. I don't know what a projection is, what a formant is. I don't even know if formant is something they use in vectors or if I'm just like hallucinating that either. Like this, like I'm hungry. is actually getting like so absurd. I genuinely don't know what he was talking about for most of the class. And I'm not really sure why. I think it's because I wasn't really paying attention. But yeah, I don't know. We learned some stuff, like the law of cosines. Like, you know, say we have a triangle, just a calm little triangle. A, B, and C, and then this we'll call alpha, beta, and then gamma. That looks like a sped delta. Whatever. Doesn't matter. I'm just gonna draw those in so then it's like clear that it's like angles. If we draw this out, the law of cosines, a squared equals b squared plus c squared minus 2bc times the cosine of alpha. Yeah, that's how it works for the other one. Like if we're trying to find, you know, c squared, it would be a and b, and then ab, and then we'd use gamma, like whatever the opposite angle is. Makes complete total sense. Shit out, check this shit out, check this shit out. Yeah, right triangle. C, A, B, and we know this shit is 90. I'm genuinely worried about the wrong stuff right now. We got alpha, and then we have beta. A squared plus b squared equals c squared, right? I feel like that's common ball knowledge. Well, the reason this part isn't there, let me move this over. The reason this part isn't even there is because the cosine of 90 degrees equals 0. So minus 2ab times 0. So this entire term literally just like drops out. You feel me? So that was pretty cool. I didn't know that. I didn't really pay much attention in trig, I'm not gonna lie. I barely passed that class. It's not my proudest moment. And that's one thing we learned. Another thing was he used a word G, and Kernett, my physics teacher, Mr. Kernett, used the word normal in like a similar way. It means like perpendicular to, or like in a I don't know, bro. He said essentially that if we had two, damn, bruh, if we had, let me scroll, two vectors like this one here and this one here with an angle theta separating them, let's call that A, B. We obviously have that. Wait, how do you do this again? If I'm gonna be honest, bro, I'm not actually like that sure like what's going on. But I remember it was like, I don't know. Big thing about vectors that's really important is y'all see this plane here. If we had a vector in this dimension, like a vector in the y dimension and then a vector in the z dimension, they can make up this entire plane, and that's what a span is called. If you have two vectors, they can make up an entire plane in 3D space, like any combination of numbers, and then other vectors can make them up, I'm pretty sure. So essentially, A is made of A1 and A2. And then B is made of B1, B2, and we want to convert it into different directions, I'm pretty sure. So what we're trying to do is to get this shit to be 90 degrees. So one's in one direction and then the other's in the other. We can do that by doing a projection. So let's make this other thing. Let's make vectors C and D. We have C and then we have D. So we have C and D. Now vector A actually equals vector C, or hat C. Hat A equals hat C. But hat B does not equal hat D. Hat D equals the projection of hat B, or it equals hat B, like the regular vector, minus its projection onto A. Now you may be asking, what the hell is a projection? Let me explain. So if you look really close, B is made up of two parts. Assuming we're talking about it in this way, we can do one line here in the A direction and then one line here in the D direction, right? Now, what we're pretty much saying is having an A direction is redundant and makes this shit way harder because we have to use like a full, like law of sine, law of cosine, whatever. So we're essentially going to project B onto A and rip that part out of B. So we're taking out the part of B that's in the A direction. B minus I am. So then we have B times. Oh wait, no, technically it's B projected onto C. Projected C, and then we have B. And then we expand this. What part of B is projected onto C? So we can expand this by saying D equals B minus I don't know. There's a really important reason he mentioned law of sines earlier. Well, let's do things this way. So if B plus this equals A, B plus, I don't know, let's call it C equals A, then C must equal A minus B. So this is hat A minus hat B. And then this is an angle theta. angle theta. Damn, what did he do? Oh yeah, so if we take like A times A, like hat A times hat A, or no, I guess that was A hat. Hat A times hat A equals damn, bro, what am I even trying to do here? This is sad. This is rough. Oh yeah, we have to use the actual like law. Yeah, so we have the magnitude of hat A minus hat B squared equals I'm pretty sure it's A squared plus B squared. Yeah. Hat A squared plus magnitude of hat B squared minus 2 times that. Because remember, that's the opposite of this. So all that's there. If we write this out, or if we wrote this out, we'll get, pretty sure it's, yeah, A squared minus, or A squared, yeah, plus hat B squared minus 2 hat A hat B. No, that's not right. A minus B squared, not their magnitudes. What the what? A minus B squared equals A squared plus B squared and then we have just flat like A and B equals -2. I'm copying this. So we have all of this. We know that if we square a vector, it's A1 times A1, A2 times A2 plus A3 times A3 plus A4 times A4. And that essentially that gives us the square of its magnitude. Right? Right? Maybe? Bro, this is actually so rough. probably should have taken my notes out before I did this. Maybe stay in your price range. Yeah, wait, that's correct. What? Yeah, because when you square a vector, that's the same thing as just having its magnitude squared. But these vectors aren't squared. Yeah, that actually does make complete sense. So these parts cancel out. The red part, and then those cancel out, and then the 2's cancel out. We can divide them both by -2 to get that A, or the A hat dot product B hat, or the dot product of A hat B hat, or A hat and B hat equals the magnitudes of A hat and B hat times the cosine of theta. So yeah, the vector product is essentially the product of their magnitudes times the cosine of theta. Yeah, I just thought I might throw that out there. Now that part's done. So here we have A and B, right? And we need to find what part of B goes on to A. We need to project B onto A, and anyway. What is that? Oh yeah. Then we'll have that. B, or yeah. B hat projected onto A slash, or C, A and C, they're the same thing. So then we have that B hat. What's equal? No. B hat equal, or yeah. What? Oh, magnitude of B hat. Hi, I'm live right now. Yeah. So I was kind of doing that. It's on camera actually. Sorry, bye. Bye. Ugh, that's rough. B hat, or the magnitude of B hat times the cosine of theta equals this shit. B hat projected onto A or C because they're equal. But there's another way to write cosine of theta though. Y'all gotta remember. Y'all must remember that B hat times the cosine of theta what the fuck? Oh yeah, two adjacent vectors. Yeah. B hat cosine of theta technically equals A hat B hat over the magnitude of A hat. Ooh. I'm gonna copy that and then like write that like down like right there. Homer drops his donut. Oh. Ooh, is that tough? Is that tough? And then yeah, A times B, assuming, you know, we're letting like A kind of be like the dummy, like here, let's call this I and then this J. A only has an I component, so that's going to be A1 and then 0 equals A1 B1 comma 0 times B2 all over the magnitude of A hat. And then if you simplify that, you just get bro, this is rough, like genuinely. It's probably it's some bullshit. I don't like this. Like, dude, like, and then I'm pretty sure that's right, actually. Wait, what the fuck? A1, B1 in the direction of A divided by the magnitude of A. You know what, bro? Fuck A. We're gonna let that be C, and C only goes up to here. That looks like a capital J. I'm gonna keep it a buck. We're gonna change all this shit. Fuck A. Bro, why wanna let me bitch? Yeah, bitch. C. Diddy. Homer drops his donut. Oh. fuck was I doing? Oh yeah, that little shit. Cause we trying to make it follow this bitch. You feel me? Oh wait. I don't even know what to do here, bro. I'm gonna keep it a buck. So we know the magnitude of C technically just equals C1. So we essentially have when we're done, we just have B1 0, and that's that, because this is B1, this is B2, and B1 B2 make B as a whole. And then if we have B1 B2 minus B1 0, then it equals 0 B2, which equals D hat. And that's what gives us D right there, because it's literally just B2. Holy shit, that took. I dropped 74% of my frames. What the fuck? Why is my Wi-Fi so bad? What the hell? I don't know what to do here. Bro, this is rough. Where's system? Oh, I'm on it. Power, storage, multitasking. Damn. Advanced network settings. Data usage. Bro, this is rough. This is like actually rough. Bro, actually, where is it? Is it in delivery optimization? Bro. Yeah, nah, this is actually rough. So this is essentially everything we got done from what I can tell in Calc 3. And then also basics it like how to, I believe it was dot product versus cross product vectors. And cross product, I'm pretty sure gives you like returns a scalar. Oh yeah, no, it has to, because dot product returns another vector in itself. This is something that College Board does that pisses me off. If you go into one of their courses, a lot, like especially like physics CM, you'll often see that like work, for example, equals force, a vector, times, they'll put a cross product, and then they'll put like distance or whatever. I don't think so. I mean, no, that makes sense because work is like a value. Like work doesn't have direction. I don't know. Force dot distance. This was a problem that we were given earlier today. It was like over 10 feet. And we gave it like 3 newtons of force. Or whatever, at like an angle. But remember, these two vectors equals times the cosine of the angle separating them. Right. So for me personally, this makes like way more intuitive sense. In terms of like the math behind it. Because you can just multiply the force like, I don't know, 50 newtons. Over 10 meters times the cosine of like 30 degrees or something. And then that'll return an answer of 500 times the cosine of 30, which I don't even know, dude. Let's do cosine of 60. That'll return you 1/2, which will be 250 joules. And I guess that's supposed to have a direction because it's a dot product. I don't know, it's weird. It's like the numbers work, but the theory doesn't fit it. You know what I mean? It's like when that one constant was discovered. I forget what it was. Ah, damn it, bro. Whatever. Listen, tomorrow's gonna be better. We just have African American studies to work on, and then we're fine. Actually, no, we have something else. I'm not doing that right now. Let's go to ethnic studies. Oh, this is due the 14th. Okay, so getting to know you survey. What else even is there? Getting to know you survey, introductions, response, and the syllabus quiz. Maybe like shit, bro. Yeah. Introductions, response. I don't know if I can work on any of these because all those are very personal. You know what I mean? I could just go over my physics final right now. So unfortunately I was banned from Claude, or not banned, but like my account was put on hold, and I'm gonna unhold it in, you know, either a few days or I might wait until I'm 18, depending on how lazy I'm feeling. But and I'm saying that because that's where the rest of the problems were. But essentially, we got my entire physics final, or I got my entire physics final, because every single, like when we were done with one half, I'd ask Claude, "Hey, we got this problem, rocket, gram, XYZ, blah 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 blah. How long was it in the air?" And I got everything right, like normal. But this is essentially what we got. So first we have a rocket problem. It experiences 8.3 newtons of upward thrust, but at 250 grams, that's less than a kilogram. So multiply this by 4, and then to get the acceleration that would deliver. And then subtract the acceleration from gravity, because that's how you add vectors. Ignore wind resistance, and then this is the acceleration we get. Integrate once, you get velocity, or integrate once with respect to time, you get velocity given time. Plug all that in, you get the final velocity when thrust turns off. Integrate twice, you get the final position when that shit turns off. It's weird. I thought those were flipped. I might be wrong, but I swear those were flipped. Whatever, it doesn't matter. Projectile motion. But yeah, here we got when velocity hits 0, which is what we use to plug in when the max height, because it goes up, stops, then it goes back down. You know what I mean? Projectile motion. This one's pretty obvious. Like that one you can just kind of pull out of your ass. I don't even need to do the double integration to kind of show that. And then I just threw that shit in for the quadratic formula on Desmos. Rotational inertia. This one was kind of tricky. So essentially, oh wait, yeah, this one was tricky. This one was the one that messed me up on the test. So first I had to convert to meters. A lot of kids probably got points off for that, but you know, it's whatever. First converted to meters. Then I used vectored math to do that shit. And then tension equals mass times acceleration over 2. Because R, that cancels out. Yeah. And then this whole thing makes sense. You just kind of, you know, add, subtract those or whatever. Wait, actually, no. What did I do here? Oh, MA minus... Okay, yeah. So I added capital MA over 2. Yeah. Integrating that twice, we get that. Oh yeah, before it hits the ground, yeah. Carnival ride, this is a fun one. Essentially, you're given a coefficient of friction. And you need to, like, just see how fast do we have to go in order for the people to be held in there. Like, you're given a tube. I'm going to copy this. And it's like, this is like an actual thing. Like, this is like an actual carnival ride, you know? So it's kind of lit, actually. I'll say actually way too much. So essentially, you have like a person in here, and there's friction, right? Like, they're not just like sliding down. There's friction like holding them against the inside of the wall against gravity. But you know, how quickly do they have to be spinning in order for the centripetal force to be great enough to do all that shit? Bro, what the fuck am I talking about? This thing pushing inside is actually what's applying the centripetal force, and the normal force is the same strength. So then it's essentially the centripetal force times the coefficient of friction, and then we just have to figure out the minimum speed it needs for the centripetal force to be big enough. Cancels out mass. It's so crazy that mass doesn't matter. That like a big ass dude could be going the same speed as like a little twink, and they'd both stay in there. And as a little twink, that's not offensive. Projectile motion, block A with a mass of MA. No, 15 kilograms, just sliding down a ramp. This one's kind of fun. Yeah, it just slides down and then runs into something. So first we got the potential. So given that it's not moving, kinetic energy is 0. Given that it's not moving, this is its gravitational potential. And then I said, given that, you know, it's at the lowest level possible there is, like there is no potential given, you know, the same initial value here. What is this? You know what I mean? Yeah, kinetic energy is equal to the gravitational potential when kinetic energy is 0 as when this is 0. I'm so bad at explaining this stuff. I'm sorry. I literally like went to sleep at 4 and then woke up at like, I don't know. Anyway, so we know it's energy and shit. 1/2 times the mass of block A times velocity squared. That's just, you know, getting its kinetic energy. So we can get that its velocity equals the square root of 2 times gravity times how, you know, how far down it went. I'm just yapping at this point, like, actually. And then this is just solving for momentum. Not even for momentum, like we already have the momentum. Solving for the velocity of both of them together given the momentum. And then we just use free fall with an initial height of 30. Not accounting for wind resistance in order to get that speed. And then the bullet. I didn't even solve the bullet one on here. So I guess I only have 5 out of the 7. Anyway, that's gonna be all, guys. I dropped like 73% of my frames, which is really embarrassing, but you know, it is what it is. I'm gonna dip out.